Hello, everybody, and welcome back to another episode of our Chromebook Classroom. Today, I am here with a new kid on the block, part of our new learning services team. He is here to shake up all things math in junior high. Good morning, Connor. How are you?
I'm doing well. How are you?
Good. And you know what? I know we've gotten to get to know each other over some of the exceptional work you've done this year, but not everybody knows who you are. So why don't you give us a little introduction this morning?
Okay, my name is Connor Renshaw, and I'm working as a math consultant specifically in grades 7 to 9. I've had a chance to meet a lot of teachers in doing this role already, so my name is out there a little bit, but for those of you who don't know me, my name is Connor Renshaw.
I love it. And I'm so excited about being able to use the tools you're showing us today, because I think sometimes junior high can get that bad rap of let's just bring out the textbook, let's just bring out the paper, and we forget that we have these digital tools. And you're not going to show us how we can use technology to support junior high mathematics, but you're showing one of my most favorite apps, these math learning center apps, which really traditionally a lot of people I think thought were only for elementary. But my goodness, you and your counterpart, Darren, have some amazing ways we can use this for junior high. So I know you were saying this is really going to help us with student understanding and differentiation, and I can't wait to see what you have for us today.
Sure. Yeah, it's exciting. So we're going to look at one of the tools in particular from the Math Learning Center. These are Chrome apps or online apps that you can use with your students. And the one that I'm going to focus on today is actually the Partial Product Finder. Now, the reason why I'm focusing on this one is, as you probably know, in junior high, we've been starting to explore some calculator-free assessments and looking at calculator-free strategies. And what we've seen from the data that's come back from that is that multiplication is an area that's deficient across our division. And so looking at how grade 7 students and how grade 8 students in particular are multiplying, there's some big misconceptions that exist out there in terms of how students are performing their multiplication. And so what this partial product finder can do is it's actually a conceptual model of multiplication. So it's something that can be used in the classroom, and it can help in terms of differentiation, because it's a strategy that can be used for something as simple as 8 times 7, or it can be used for some of the larger number multiplication. And it can even then be used when we start to multiply decimals, fractions, looking at perfect squares in grade 8. And so we'll kind of make that connection to how this model works.
That's really, really exciting, because again, I love what you're showing is we're still looking at visualization and visual tools to help support our learners. This isn't just about relying on the algorithmic writing of the equations. We're able to combine both worlds, right?
That's right, yeah.
I love it. And now the Math Learning Center is, for anybody watching, 100% free, works on all of our devices, but especially within Chrome and the Chrome browser. And the Partial Product Finder was new to me, Connor. You showed me this one for the first time, that they just recently added to the tool set.
Yeah, it's an exciting one. It doesn't have the Chrome app as of yet, but it does have the web version of it. And so that's what we'll kind of be exploring a little bit today. Some of the details about it that are found on the website, it talks about how the tool helps students develop flexibility and conceptual understanding required to build fluency with the basic facts and strategies of larger numbers. Tricia mentioned that it does usually kind of say it's ideal for elementary classrooms, but as we look at some of the foundational skills that are showing up as being deficient in our division, those foundational skills are often from earlier grades. Multiplication, for example, is first explored grade 3. And looking at 2-digit multiplication is something that gets really explored in grade 5. But as we look at our students in grade 7 and grade 8, it's a foundational skill with which they're still deficient. Mm-hmm. And so we'll go into this partial product finder. We'll go to the web app, and I'll show you a little bit on how it works. So. Hey. When we first go into the Math Learning Center, we're presented with a whole variety of different apps. And like I said, I'm going to focus on the Partial Product Finder. So I'm just going to open this web app. And what you get is you get an initial grid that's representative of 5 times 5. Within this partial product finder, you can perform multiplications up to 50 times 50. So we're going to start with something really simple, and we're going to start with a basic fact that for whatever reason students really seem to struggle with, and that's 7 times 8. I don't know why 7 times 8 seems to be the one fact that students always tend to forget, but when we're working with struggling students that don't necessarily know their basic facts, we need to provide them a strategy to help them still progress forward in that. And so often when I ask teachers, what do you do to help the students with their basic facts if they don't know them? The response I often get back is, well, they need to know their basic facts. And so, we can play that circular argument game all day long talking about, well, what do you do to help them if they don't know their basic facts? And then the response, well, they need to know their basic facts, and around and around we go.
Right.
What I like about this strategy is it does bring in that universal design for learning. So it's a strategy that students can use to perform something as simple as 7 times 8, but it also can then be expanded into larger number multiplication, or multiplying decimals, or multiplying fractions. So what we can do with this is it allows students to break an unknown fact. So if they don't know what 7 times 8 is, they can start to play with it and break it down into facts that they do know. So, for example, a lot of students seem to know their multiplication by 5. So if we grab this slider and pull it down, we can break 7 apart in 5 plus 2, and we can even break 8 apart into 5 plus 3. So what this partial product finder is doing is we're still finding in the end 7 times 8, but we're breaking it down into partial products, pieces that maybe these students do know if they understand their multiplications by 5 or by 3s or by 2s.
Okay. Wow, that's amazing. And so they can just drag and slide, they can break that down, they can see what they're doing. And I love that you can make this more complex so you can learn this tool at a basic level and they can expand their understanding. But you've taken this like another whole way, because you're saying students can do this, but you have a way for students to actually be able to utilize this visualization in addition to be able to putting that in its written form.
That's right. So when we start to get into talking about the algorithm and, teaching what I guess we refer to as column multiplication, there's actually a direct link into how this is done. So if we take something a little bit larger, like if we did something like 17 times 13, this is not a basic fact that students are expected to remember. Normally, how we would teach this is we would demonstrate it using column multiplication, taking them through that algorithm. What I like about this is they can now start to break this apart into, again, known facts. So a nice discussion to have with students is, why is it simple, or do they understand that it's simple to multiply by tens? If they have a decent understanding of place value, they can now break 13 into 10 and 3 and 17 into 10 and 7. And in doing this, we're now multiplying by multiples of 10. Students will often find this relatively simple. Most students will know 10 times 10. But even the idea of multiplying 3 times 10 and 7 times 10, generally students will have an easier time with that. Now, what I like about this, and what I often will get my students to do, is I will use even a snipping tool to then get them to share how they're evaluating this. And if you notice at the bottom here, we're never really presented with the answer at this stage. You can get the answer if you decide to click on this little eyeball here, and it will, present what the actual final value is. But with that hidden, it's more about the process than it is really about the answer. And so if we were to pull up a snipping tool.
I love this. And if you're on a Chromebook, remember Control-Alt and the Windows switchers key in the middle of your screen. It looks like a little bread tub. We'll give you a screenshot as part of this this video so you can see what that looks like. But so simple. Just grab a little snip here.
Yeah, so we'll grab a little snip, and then it'll put it on your clipboard. And what I would do is I would use something like a Jamboard and have students then paste in their thought process. So now you can start to compare how some students are doing this compared to others. if the students are struggling to multiply by 10, they could, in theory, even break this apart further by grabbing another slider, and maybe they're now using those factor of 5 again, right? I mean,
Wow.
we can start to talk about whether this is the most effective or efficient strategy, but it's that universal design where you're giving students entry points into being able to still perform 17 by 13 with whatever facts they do actually know.
That's amazing. And now I noticed you jumped over to Jamboard. You put that image right on there. Students really could also just grab that inking tool and they could complete the algorithm beside that visualization. They could have everything right here on this Jam frame.
That's right, yeah. And so I've shown a little bit in our slides here. If we jump back to our slides, I have shown a little bit about how it actually relates to that algorithm. So teachers will often present the algorithm in one of two ways. This is one way that is often shown, and you can see a visual link of where this 51 is coming from. That 51 is actually 17 by 3.
Right.
The 170 is the 17 by 10. So there's a link between what they're seeing visually on this partial product finder with how the algorithm is presented. Another way that sometimes teachers will present it is by writing it out like this. And so you can see now where that 21 is coming from. That's 3 by 7. You can see the 30 is the 3 by 10. What I like about the visual representation with it is that we don't get the students that get confused as to, considering this as 3 times 1 rather than 3 times 10, and forgetting to put the kind of magical 0 that just appears and nobody really knows why it appears. And so the visual representation is even supporting this level of instruction.
That's amazing. And I love the way that you were able to use the highlighter tools, color coding, where that was on the blocks in the Math Learning Center, where that was in the algorithm. What a great visual connection for, like you said, all of our students. This is great for everyone, but what a game changer for any of our students that are struggling to still use that elementary math to support their understanding in junior high. This is unbelievable. Now, everybody who's watching, just so you know, these slides Connor has presented are available below the video, including screenshots of how to do a screenshot, and just some of those examples of being able to have the algorithm beside this partial product finder. I think this is such a fantastic way to be able to do this. This actually is supporting the Math 7 to 9 program of studies. This isn't just remediation. This just isn't for students that are struggling. This really does support our grade level expectations for 7 to 9 junior high math, right?
Yeah, so I'll make a link to how we can kind of start to explore this. Now, the actual app itself is limited to whole numbers. And so when we start talking about multiplying 2-digit numbers, the partial product finder is limited to using whole numbers, but the conceptual idea behind it is something that then we can transition into actually performing multiplications of decimals or a couple other grade 8 outcomes. So if we kind of skip ahead here a little bit, I'll just point to this one before we kind of move on. When we start to even get into something like 24 by 27, there again is that universal design for learning. Some students may not yet be ready to multiply by 20 and may not have that understanding. They can still break this apart into groups of 10 if they find that to be something that's a little bit easier for them. But if we look at now our specific programs of studies, I just went through and I grabbed the 3 outcomes here that have a direct link to this conceptual model. And so if we look at the grade 7 outcome of demonstrating an understanding of multiplication of decimals, which was one of the areas that we saw as deficient in our division looking at our calculator free data. Well, if we start to now redefine what the lengths might represent, instead of seeing this square as being a square of 10 by 10, if we redefine the lengths as being 1, that little pink square now actually represents 1/100th of the area that's there. And so when we start to explore this, we can now make a link to how, rather than looking at something like 17 times 12, we could actually look at 1.7 times 1.2. The conceptual model is not changing. We're just kind of changing our perspective a little bit.
That is such an amazing way to look at this. I would never have thought of this. You are brilliant. I love it.
Yeah, so it's again expanding on that universal design. Well, we may have students that are still at the stage of doing 17 times 12. They can use this conceptual model. That same model can then be used for the students that are progressing ahead and starting to look at 1.7 times 1.2. I'll show you my favorite link to this is actually a grade 8 outcome, and it's looking at perfect squares. This conceptual model will actually help students start to see patterns in perfect squares. Often we have students that have memorized perfect squares up to 12 times 12, knowing that that's 144. But if we start looking at some of the larger perfect squares, so the first example I took here is 14 squared. If you notice in the conceptual model, we have some patterns that start to develop. So if we look at it being 14 as 10 plus 4 and 14 as 10 plus 4, we're always going to get a perfect square in the top left here. In the bottom left, we also get a perfect square of 4 times 4. These other two rectangles, because this model now is not a rectangle but a perfect square, meaning our lengths are the same, these two other rectangles will be identical. And so in seeing that, we actually know if we just found what the area of one of these rectangles is and double it, we now actually have a pattern to establish what is 14 squared. Rather than having students going through the algorithm of doing 14 times 14, we now can see a pattern. And you can get some students that are maybe higher level thinkers at this stage, starting to be able to do these patterns in their head. So 14 squared would be 10 squared plus 4 squared plus double 10 times 4. And so as students start to think about this, we can even look at something like, 27 squared. That same pattern is there if we look at it as 20 plus 7 and 20 plus 7. We see a perfect square, we see a perfect square, and we see identical rectangles. So that pattern now is becoming established.
That is so fantastic. I love that we've gone from, grade, 3, 4, 5 mathematics all the way up into grade 8 and 9. We're still able to use these tools. And I think it really goes to show that the idea behind this is the tools still support those grade level outcomes, but are we choosing tools that can really offer those multiple entry points, like you've said, that low floor, high ceiling, because everybody needs to visualize. Like I'm learning right now, you're blowing my mind because I'm like, oh, I never thought of being able to do it like that. We can totally take it beyond that face value of the tool. That is amazing.
Yeah, and that's what I like about the conceptual model. And I mean, a lot of my experience comes from teaching high school math, and the links for this model even extend beyond junior high. And so we're now giving our students a strategy that doesn't expire, if we want to call it that.
Right.
I mean, the traditional algorithm to perform 2-digit multiplication, it expires when we start multiplying polynomials, right? But this strategy can actually now be applied to multiplying polynomials. It can be applied to factoring polynomials at the high school level. One other outcome that can be related to it is the idea of multiplying mixed numbers. Often the strategy that teachers will employ to, have students multiply mixed numbers is they will first get them to change it into an improper fraction. And then they multiply numerator and multiply denominator. But there is actually a way with this conceptual model to look at the product of 2.5 times 1 1/3. And we start piecing together all of the little areas that make up the product of 2.5 times 1 1/3. And so we never actually have to change this into improper fractions if we start to explore, 2 times 1, 1 times 1/2, 2 times 1/3, and 1/2 times 1/3. Now, obviously in this strategy, they're going to then need to add up these terms, but this is a grade 8 outcome of multiplying mixed numbers. And in grade 7, they've explored how to add and subtract fractions. So there is some prior knowledge now that they can return to and use in terms of adding up these fractions to now determine what is the product of 2.5 times 1 1/3 without ever having to change it into improper fractions.
That is awesome. Well, I love absolutely all of these strategies, and I love how you've taken one app. There's so many apps on the Math Learning Center. I know Darren, your counterpart, is going to be here showcasing another one of those apps in our part 2 of this video. But if you are looking for more mathematics resources to be able to support any of your junior high programming, everything that Connor and Darren has made is attached below this video. Like I said, along with the presentation and all of those additional resources, feel free to reach out anytime. I know that they could talk your ear off all day about all things math. But thanks for being here, Connor. I learned so much today, and I'm like really excited. Math used to kind of freak me out, but it's things like this that make it accessible, I think, for teachers and for students.
Yeah, thanks for having me. It was fun. And like you said, if anyone else wants to talk about multiplication, I'm always willing to talk about multiplication.
I love it. Thanks so much. Bye, everybody, and we'll see you in the next episode.